Hi, thanks for joining me today. I'm going to be going over a very interesting limit problem from the IIT JAM paper, which I believe is an entrance test you've got to do if you want to study a master's in India. Or I don't know if it's a particular university in India, but if anyone knows any more information about this exam, let me know in the comments. Anyway, we want to know what is the limit as n goes to infinity of the sum from k equals 2 to n of the square root of n plus 1 minus the square root of n, all divided by k times log k squared. If you want to have a go at this problem, pause the video now and give it a go for yourself, and I'm going to dive straight into a solution. Okay, so thankfully this limit problem is actually not too difficult to solve, just use a trick or two. So the first thing I'm going to do is just take out the root n plus 1 minus root n. So this is the limit as n goes to infinity of the square root of n plus 1 minus the square root of n, and then multiplied by this sum here, the sum from k equals 2 to n of 1 over k log of k squared, like so. And now we're going to think about this thing here. And well, it's got an n in it, so I'm just going to say, well, what if I replace the n with infinity? So let's think about the sum from k equals 2 to infinity of 1 over k log of k squared. Now, I claim that this is a convergent series, that this thing converges to a finite number. How do I know that? Well, I can actually just apply the integral test here. So the integral test, what is that? That says if I have an infinite sum of non-negative terms, and clearly these are all non-negative, then the sum converges if and only if the corresponding integral would converge. In this case, the corresponding integral would be the integral from 2 to infinity of 1 over x and then log x squared dx, like so. And so we just need to prove that this guy here converges, which will tell us that this guy here also converges. How do I know this converges? Well, I can just do a nice substitution here. I'm just going to say u equals log x. And if I have u equals log x, this integral here just becomes the integral from log 2, to infinity. If u is log x, then du will just be 1 over x dx. So this 1 over x dx becomes my du. And this will just be 1 over u squared du. And now this is a straightforward integral to calculate. It's minus 1 over u, and that's from infinity to log 2. And this is just going to be 1 over log 2, like so. And in particular, it's a finite number. And so therefore, this guy here converges. And so therefore, this thing here also converges to a constant. I'm just going to call that constant c. I don't know what c is, but it's a finite constant. And so therefore, I can say that this thing up here is always going to be less than or equal to c, regardless of what n is. And so therefore, this thing here is going to be less than or equal to the limit as n goes to infinity of c times root n plus 1 minus root n, like so. And now I just need to figure out what this is. This is very nicely just going to be 0. How do I know that? Well, you can kind of prove this rigorously, maybe like by taking the difference of two squares or something like that, but it's actually not too difficult to just convince yourself that this is true. If you think about the difference between consecutive square roots, for example, between square root 1 and square root 2, the difference is about 0.4, but if you look at the difference between square root 100 and square root 99, that's going to be much, much smaller. And as you take n bigger and bigger, the difference between the square roots of consecutive integers will tend towards 0, and so therefore this thing here tends towards 0. And also this thing here is clearly going to be non-negative for all values of n, and therefore this limit, therefore by sandwiching, must be 0. I hope this solution has made sense, and hopefully you've enjoyed this video. Do let me know if you enjoyed this problem and you want to see some more problems from this test. I'm not too familiar with it, but the problems do seem quite interesting and challenging, so hopefully you can make some more videos on that. Anyway, I'm going to stop waffling. Thank you for watching. I'll catch you in the next one. Have a great day.